right, so the next topic is within our functions conversation here is on the notation that we use with functions, which you may or may not have seen before. The things that students tend to remember the best about functions are vertical line test and that f of x is like y. those are the two things that I think students remember the best. So let's talk about what that means, that f of x is like y. It's kind of true. But when we know an equation represents a function, for example, if you remember anything about your basic line y equals mx plus b, you know that y equals 2x plus 3 is just the graph of a line, right? Like this is just the line that would have a y-intercept at 3, and then from there you would go, and you don't need to graph this, but you would go up 2 over 1. So this is your graph of your line, and you know that a line would certainly pass the vertical line test. So like we know that equation, we know it represents a line, we know that line passes the vertical line test, there's no repeated x's. So it's a function. So can we convey that information maybe a little better to the mathematical reader, if you will? And we do. So what we say is that we are going to replace the output variable, which most often is y. We are going to replace that and we're going to name the function. And we're going to name it f or g or h or whatever we want. And then in parentheses, we're going to put the input variable or the independent variable that we're going to basically see in the equation on the right-hand side. So for example, y equals 2x plus 3 there might become f, that's just the name of the function, and then the in parentheses x, kind of like parentheses in English, it's additional information. So that's telling the reader that the input variable that you should see now on the right-hand side of this equation should be an x. And that, of course, is what we would have. F of x equals 2x plus 3. Okay, so now we want to start to get used to this function notation. So let's say we have number 1 here, where we are asked to evaluate f of 2. Okay, so what does that look like? So if I am asked to evaluate f of 2, that says every place where there is an x, we want to go back. So think about right there, there's your x, it's now going to be 2. Every place where there was an x, we're going to go in and replace that x with a 2, and then evaluate and see what we get there. So here it would look like negative 2 squared plus 2 times 2 minus 1. So remember that negative in this case was never part of that squaring. It's only the square applying to the x. The x here is 2. Only the 2 is being squared. So what we're going to have then is going to look like negative 2 squared is 4 plus 4 minus 1. And so we now end up, of course, with 0 minus 1. So we just end up with minus 1. So if I just say evaluate f of negative 2, or f of 2, excuse me, I could have been writing f of 2 equals the whole time. F of 2 equals negative 1. So negative 1 would be your answer if I said evaluate f of 2. Now, what does that mean? It means something you already know, we just have it maybe in a slightly different notation. So in parentheses, let's just put off to the side, and let's just note something here. When you just found that f of 2 is equal to negative 1, that is the exact same thing as the ordered pair written as 2 comma negative 1, and saying that that is a point that is on this function f of x. Like it's on the graph of, it's a point that satisfies the equation of, in this case, f of x. So the order kind of stays as you might expect, right? So this is the input, that is the x, the independent variable is first. What you get out is the dependent variable, what is often the y, and that's what we write second. So writing it with function notation versus the ordered pair notation. Just want to be used to both. But here, if I just said find, f of 2, f of 2 is simply 1, -1. That is your answer. All right, let's look at another example here. So let's look at g of x is equal to -2x cubed over x squared minus 1. And this time, let's evaluate g of -2. Okay, so g of -2, so that is going to say we want to think of the x now as being replaced with the -2. So we want to go into this function here, and every place where there used to be an x, we want to replace that with -2. So -2 is going in for all of our x's. Okay, so let's see what we get here. So we would now have in the numerator -2 cubed, -2 times -2 is 4, times -2 would be -8. And then in the denominator, the quantity -2. So this time it was squaring the entire x. The entire x was -2. So -2 squared would be our 4, and then minus the 1. So we end up with a positive 16 over 3. So again, this is what g of -2 is. So my answer, 16 over 3. So it's important to realize that this f of -2 or g of -2, that does not mean multiplication. Again, that's just notation kind of saying we've just went into the g function and we subbed in -2 for x and we got back 16/3 for y. So again, as we're kind of getting used to this relationship, it's recognizing that what we just found, kind of big picture, g of -2 was equal to 16/3 is equivalent to, in ordered pair world, just saying -2 comma 16/3 and saying that that is a point that satisfies g. It's on the graph of g. It satisfies the equation of g. All of those are synonymous. Okay, so we're going to continue here using our function notation. Now we're just going to answer a similar type of question in 3A here that we did in number 1 and 2, but we're doing it with the graph. All right, so this is saying we want to look for, again, keep in mind, this input here is 0, or in the next one it's the -3, and that is our x value, right? Or the independent variable. Again, more commonly for us it will be x. So as we look at part A, f of 0, we want to go to our graph over here, and we want to go to where x is equal to 0, which is right here, and then look for where that point is on the function and figure out what the y coordinate is. Now again, we're going to have to approximate this a little bit here because it looks like it's maybe just a little bit over 1 here at this, I'm going to say 1.2. The thickness of my dot now, I look like I'm maybe higher than what it is, but the original graph, it was just a little bit over 1. So at f of 0, if we had had the equation, we would have subbed 0 into the equation. We would have solved for y, and we would have gotten that y is 1.2. When we have the graph, we look for where that point is on the graph at x equals 0, and again, that y value, that's the output that we're looking for. All right, let's look at another one here. So now let's take a look at f of -3. So again, I'm going to -3 on my 1, 2, 3 here. So here I am at negative 3, and I'm going to where that point is on the graph. And it looks like that's down here at negative 3 as well. So here, when I went to where x was equal to negative 3, it looks like the y is negative 3. All right, so that means when I sub in negative 3 for x, I actually got back, in this case, negative 3 for the y. Okay, these are the same thing. If it would have been easier for you to initially think of this, it's kind of saying complete the ordered pair. 0 comma what is on the graph, or negative 3 comma what is on the graph, right? Those are the questions that we're seeking when we first are looking at those problems. So if maybe just kind of, thinking in those terms makes it easier, I don't know, just a little different way to kind of think about that. Okay, the last one here is a little different because this time, notice it says for what x. Last time we had the x and we were looking for the y. This time they're saying for what x is the f of x. So remember, this entire f of x is really saying the output, or in this case, the y. So as we look at this one, this is a different question. This time we are looking for the x and we're given the y. So we're trying to think about what x would satisfy the ordered pair or be on the graph of something comma where the y coordinate is 6. So we're going to where our y coordinate is 6, which is up here. And now we are going to the graph to look for what that corresponding x coordinate is. And hopefully what you kind of notice on this one is this time we have 2 different points where the x coordinate is equal to, where the y coordinate, I misspoke there, where the y coordinate is equal to 6. And it looks like, again, these aren't like perfect integer locations, so we are going to estimate, and I'm going to say that maybe this one's just at the halfway mark at negative 4.5. I'm going to say this one's at, like, again, the halfway mark, we'll say it at 3.5. All right, so those are the x values, 2 of them here, that would satisfy the ordered pair that x comma 6 is on the graph. So our final answer here, we have, and we have to just write it out as x equals negative 4.5 and x equals 3.5. So this time we were looking for those 2 x values. All right, so still working with function notation, this time just getting the information from a graph rather than from an equation, excuse me. All right, so number 4, let's end with this one here. It says the height in feet of a basketball at any time t seconds is given by this h of t function. So we've named it h, kind of describing height maybe. So it's really like a formula. It's like the formula for height equals. The of t is that notation telling the reader that t is the input variable or the independent variable. It's the variable we're going to see on the right-hand side. All right, so in this first example, we are looking for what is the height after 1 second. So this is very clearly our value for t, and we're trying to find the height. So using function notation, we would express that as evaluating h of 1. So that means we want to go into the h function, and every place where there had been a t, we want to replace that with 1. All right, so that one is nice to work with. Negative 16 plus 20, that'd be 4, plus 6 would be 10. So what we end up with here is just h of 1 equals 10. So 10 feet, that is the height after 1 second. All right, so the second question, really similar. It just brings up something that you're going to often see in terms of the language, which might ask for an initial height or when the ball was initially released. And so we want to know that that is going to correspond to, when the time is 0, like at 0 seconds. So same premise, the height at 0 seconds, so right before we let it go there. So that's going to mean we are looking for, and the arithmetic here will be even easier, h of 0. And so of course I'll write it out, but in your first couple of terms there, as soon as you have a t, that t is going to go to 0. Those first two terms would have just been 0. They would have been gone. And then 0 plus 6, of course, would have just given us 6 feet is our initial height.